So, now we are going to discuss circular motion. So, see here, when an object moves in a circular path, object is said to have circular motion. Suppose any object is at this point and it is moving in a circular path like this. I have taken here anti-clockwise motion. This is considered, this we take as the center of the circular path. Suppose initially object is at point A at t is equal to 0 when we are starting motion. Now, after some time this object reaches to the point B and then angle made by this arc is theta over here. So, see here, when the object is going A to B, angle subtended by this length or this arc at the center is theta. This theta is known as angular displacement. So, theta is called angular displacement. So, simply the angle turned by the body moving in a circular path in a given time interval is known as angular displacement. Its unit, SI unit is radian. So, SI unit of angular displacement is radian. If the body have angular displacement, it must have velocity also. So, the velocity we take here, angular velocity. So, see here, angular velocity represented by omega, it is equal to change in angle, that is a angular displacement divided by time interval. This is known as average angular velocity, because there is a total change in angular displacement divided by total change in time. Now, we can write, if you are taking here delta t tends to 0, then you can write omega is equal to d theta upon dt. In linear motion, we have done velocity is equal to ds upon dt, that is a displacement upon time. In circular motion, we take here angular velocity this much. This is called instantaneous angular velocity. Its unit is radian per second. So, unit of angular velocity is radian per second. Angular acceleration alpha is equal to change in angular velocity divided by time interval. If you are taking here delta t tends to 0, that means very small time interval, you can write alpha is equal to d omega upon dt. Also, we can write d upon dt into here d theta upon dt. That can be written d square theta divided by dt square. So, this is angular acceleration alpha. So, when the body moves in a circular path, it has got angular displacement, angular velocity as well as angular acceleration. Now, see here, angular velocity, angular acceleration and angular displacement are considered vector quantity. Suppose if you have taken a small angle, then angular displacement is a vector quantity, because for the small angle it obeys commutative law, but if it is for the large angle it does not obey. So, for the small angle we can take angular displacement is a vector quantity. If it is a vector quantity, then what is its direction? Just here you have to see the way of the movement. Suppose the body is moving in a circular path in anti-clockwise direction. Just use your right hand and keep your right hand in this way. Move the fingers, just turn your fingers in anti-clockwise direction and thumb is going up. This thumb is actually point along the axis of the circular path, and this is known as direction of angular displacement. So, if the body is moving here in this path, so angular displacement and angular velocity, everything has direction vertically upward here. That means is here along the axis of the path, along the axis of the circle, but it is here outward. So, if it is anti-clockwise, it is upward here like this, and if it is a clockwise, that is downward. So, angular displacement, angular velocity and angular acceleration are vector quantity. Their directions are given by right hand rule, right, and in case as I have shown here, this is for the anti-clockwise direction. If you are taking for the clockwise direction, body is moving like this, in that case angular velocity will be here. So, in this case this angular velocity and this is angular velocity. Now, see, in circular motion we have done angular velocity, angular acceleration and angular displacement. Now, see, if the object is moving in a circular path, this point is O and this point is A, object is moving like this. When object completes one revolution, it starts from A and reaches to the point A, we say the object has completed one revolution and the total angle made at the center is, that is 2 pi radian. So, in this case total time taken to complete one revolution is capital T, here is T, and this is known as time period. This is known as time period. So, the time taken by the body to complete one revolution is known as time period. So, if the body has completed this one revolution here, then we can write omega is equal to 2 pi upon T. 2 pi is the total angle subtended in one revolution and the total this capital T is the total time taken. So, and here we can also write 1 upon T is called frequency. Frequency means number of revolutions per second. So, unit of frequency is hertz, that is represented here Hz. Number of cycles per second, we can say number of revolution per second, that is known as frequency. So, now in this case we can write this here. So, this can be written 2 pi f. So, omega is equal to 2 pi f. Omega is known as here angular frequency. So, number of revolution per second is known as here angular frequency. So, this is about omega frequency, this is about angular velocity. When body moves in a circular path, this is the point O, as this is center, this is the here A at T is equal to 0. Now, suppose body is moving in a circular path, at any point body reaches to the point B. This is known as theta here, angular displacement. This is the length of arc or the length body has covered. So, when the body is moving in a circular path, it is covering two types of distances. This is a linear distance and this is angular displacement. So, there are two types of motion. One is a angular displacement, angular motion, and another one is also we can say that is called linear motion. So, body have two types of velocity, angular velocity as well as linear velocity. And see here, in circular motion, direction of the body keeps on changing continuously. So, suppose this is the displacement or the linear displacement, I have taken delta L, and time to go from A to B is delta T suppose. So, AB is length of arc which is equal to delta L and time is equal to delta T. We can write here velocity is equal to, that is a linear velocity, delta L, that is change in displacement, or that is a displacement divided by time, delta L upon delta T, this is called V. And we can also write theta is equal to delta L upon R, this is R is radius. So, here we can replace the value of delta L from here, or we can write delta L is equal to theta into R. Now, put this is here, you will be getting V is equal to theta into R upon delta T. In this case, this theta upon this is known as angular velocity. So, we can write v is equal to omega into r. So, this is the relation between linear velocity and angular velocity. So, v is equal to omega r, and we can also write v is equal to omega cross r. This is in a cross product of the two vectors, because omega and r both are the vector quantities. See, the direction of omega in this case is to this side, direction of velocity radius vector if you are taking to this side, and now velocity if you are taking that is to this side, that is tangential. So, this is about the relation between linear velocity and angular velocity. Now, see, next part is here relation between linear acceleration and angular acceleration. Because when the body is moving in a circular path, it has both the velocities, linear velocity as well as angular velocity. We know this relation v is equal to omega into r, just we have derived this relation where v is linear velocity, omega is angular velocity, r is radius. Now, what we can do here, we can write dv upon dt, we are differentiating velocity with the time, and here d omega upon dt into r, where r is constant. So, see here, this is known as a and this is alpha and this is r. So, in this case is here, this is a is equal to alpha r. A is linear acceleration, alpha is angular acceleration and r is radius. So, the relation between linear acceleration and angular acceleration is this. Now, after discussing all these basic terminology, we will come to the uniform circular motion.